Hey guys, it's your boy Chili here. Welcome back to Hardware 3D. In the last video, we implemented the parsing and the loading of a scene graph, a scene tree. But we didn't really explore the tree in any depth. We just implemented it and we verified it worked on one model. But now I want to actually dive into the tree, explore it, see how it works when it's loaded, see some other things. It's going to be cool. So here is basically the finished product of this video. And you can see here I've added a window that allows us to navigate the scene tree. And you can see here that we've got some hierarchy of nodes, and it'll also allow us to apply transformations at each of these nodes. So let's take a look at how that was implemented. It's a bit of a journey. That tree widget that you saw with the collapsible nodes, that is a widget that is provided by ImGUI. So let's take a look at the first commit that we have here and see what has changed. So in mesh.h, you can see, first of all, I've added name to each node, and the constructor is going to take the name. So now every node is going to have its own name, which will make it a lot easier to identify them in the tree. I've also added a function here, show window. That's going to show that window that I've just shown you previously. And a function render tree in node that is going to recursively render the nodes in that tree. So mesh.cpp, let's see what we've got here. We include ImGUI in here now because we're going to be doing some ImGUI stuff. You can see here now when we construct a new node like we're doing here, we've got to pass in the name, and that is just node.mname. And then we get the C string from that. If we scroll up, what do we have here? Well, we got a whole bunch of stuff added. Obviously, this is going to be the show window function. Let's see what that looks like. Well, we have two columns. So here is how you do columns in a single window. Call it, give a number of columns. I believe this is to say that we want a divider drawn between them. And then you call next column when you want to start the second column. The first one is going to call that recursion, start the recursion for generating the tree widget. And the second column is going to have all the controls for the transformation. We also see in model draw here that we are building up a transform that's going to be applied. That transform is built up from the parameters controlled here. So right now, just to start off, because I like to start things off small and then gradually build them up rather than trying to build the whole thing all in one go. I just start off by having these controls just control the parameters of the root of the mesh, or the root of the model, which is stored in model here. So now this structure has been moved into model. Previously, I believe it was in app.h here. So I'll just move that into the model part. But anyways, so we have some controls that are controlling just the base transform on the model for now. Probably the most interesting ImGUI stuff happens here in the recursive render tree, but it's not that complicated. There are two versions of the tree node function, tree node and tree node EX. EX version allows you to have differentiated leaf nodes. So you have leaf nodes that don't have any children and they don't have an expander control on it. And then you just have nodes that do have children. Tree node doesn't have that. Everything has that control on it. It's a much simpler version, but we'll start off with a simple thing. So we call tree node with the name of the node. If that returns true, that means that this one is currently expanded. And if it is expanded, then we want to recurse and render all the nodes of its children. When you're done rendering the children, you do tree pop and that goes down a level or up a level. I don't know, whatever you want to call it. And what are these other changes here? Well, obviously we're going to have to store the name of the node and then draw here. No big deal. I just replaced no except not is debug with our dumb macro that is a lot shorter, but is also dumb. And if you run that, we get our nanosuit from the object file, the wavefront object file, and we can see here are all the nodes. Notice that these are all leaf nodes. They don't have any children, but they still have this expander control on the side, and that's because we're using the non-EX version of tree node. But you can also here, this controls the base transform. It doesn't matter which one of these. Well, you can't select because I haven't implemented that yet, but you can only control the base transformation that applies to all of the nodes here. And notice here that this file does not have a hierarchical structure. I mean, it looks hierarchical. You have the base node, but then all the other nodes that actually have meshes attached to them, They're all flat. And this is actually, you cannot have a hierarchical scene structure in an object file. They don't support it. So this is all you're ever going to get. So that means we're going to have to use a different file format if we want to test this feature out. Luckily, ASIMP supports a buttload of file formats, including those that support hierarchical scene graphs. So that's not a big problem, although I did have a huge problem, and we'll get to that in a while. But first, let's just start implementing those things that I neglected to implement in this just first pass here. So the next commit here is a little bit of refactoring. I'm going to pull all the, or most of the functionality with respect to the model window. Instead of putting it directly in the model class, we're going to pull it out into its own class, kind of separate those concerns as much as possible. So in mesh.h, you are going to see this being taken out of model, and model is now going to own a model window. You might be wondering why I'm adding this destructor here, and reason why is because if you don't put your destructor in the CPP file, like I'm doing right here, if you keep it in the H file, the compiler is going to complain if you try to do unique pointer with a forward declared type. Just rename the render tree to show tree to match show window, no big deal. In mesh.h is where everything is going to be, because I actually declare the model window class in the CPP file. I don't put it in the header because the outside world doesn't even need to know about it. All the outside world does is it calls show window on the model, and the model owns this privately. So I can keep this whole class definition segregated to a single CPP file, and the outside world doesn't even know about it. That's that's the pimple idiom. But anyways, here, the renaming bullshit, no big deal. Model window. Show is basically just copy and pasted from what we had before. Get transform generates the matrix from our parameters that are controlled with these guys. And then here are the parameters. No big deal. Here we create the window, and show window just calls show on that window object here. And when we draw our model, we call get transform to get that base transform that's going to be applied to the root node of our model. There you go. So just a little bit of refactoring, hasn't changed any of the functionality yet. Now we're going to use the extended node widget, which will allow us to select nodes and also will allow us to have, leaf nodes that look like leaf nodes. So in mesh.h, I include optional because one of these parameters, this reference here that we're passing in to the show tree, it's optional because it's optional whether or not one of the nodes is being selected. So why we're doing this, we're using these references here for node index to give each node a unique integer index instead of using the name of the node as the index. It'll just be easier to use a unique integer index for each node. This will basically keep track of the current unique index so that we can guarantee that each node is allocated a unique index. And this reference here is to recursively keep track down the recursion, keep a single variable that holds the current selected index. You'll see when we get into the implementation here. So in show tree, again, we take in those parameters. We get the index of the current node from that reference that was passed in, and then we increment that reference so that in future recursions, it will have the proper index to get a monotonically increasing sequence of unique indices, to put it in, the big brain way of speaking. But anyways, tree node EX has a bunch of flags to control its options. So we want to build up those flags here. And flags are, we want it to open when you click the arrow. We want the current node to be selected only if the current index equals the selected index. And it's a std optional, so I use value or here to handle that situation of there being no selected index. And then down here, if the container of child pointers is empty, then I can we want to add the flag to show that this is a leaf node. I don't know why I call size equals 0. I've done this before, but you could just call .empty if you like. It doesn't matter. Then to use imgui to add that node, we're going to pass in the index, the integer index, pass in the flags, pass in the string, which is the name of the node. Now this stuff here is a bunch of real bullshit. I haven't looked into it, but basically when you want to use an integer as your node identifier, you've got to cast it to int pointer t and then cast that to void point. It's some bullshit. You know, ImGui, it's a cool library. It's not perfect, okay? But just, this is the way you do it. And if you do it this way, it works. Then once you have that built up, if it is, you know, if it is expanded, you're going to want to draw the children. Also, you, after generating this node, you can call isItemClicked, and that will check to see if this node is being clicked. And if it is, you want to set this the index of this node to being the selected node, so that it will be rendered with, you know, selection. But yeah, you do the recursion. You pass in, again, those referenced variables so that they can be tracked throughout the entire recursion. And at the end, you call tree pop. It's not a huge deal. It's definitely better. I mean, there's many ways you could do this with the, you know, keeping track of unique indices and keeping track of which index is currently selected. Global or static would be another way of doing it, but that wouldn't be a very good idea, because then if you tried to do multiple windows and sometime in the future, you would have a big problem. So it's much better to use references for this. At least it's better than a global. And then down here, what are we doing? We initialize the integer that is going to track the unique indices through the recursion. And we pass that in, and we pass in selected index, which is the optional. And that is held as a member variable here because we want to keep that between frames. We want to remember which one is currently being selected. And if you do that, we see we have our tree. And now the leaves actually look like leaves. They don't have the expand control. And you can select them and they remain selected like this. Now the selection here we're doing doesn't actually change anything. The transform is still being applied to the root node, but that's what we're going to do next. All right, now we're going to use that ability to select, and we are going to control the transform at any node. So in mesh.h, what has changed? Let's take a look. So I made model window a friend of node. That's going to give it access to some things that it might need. And here we have, okay, so node has a base transform, which is the transform that was loaded from the file, and then the applied transform, which is the transform that is going to be applied from the controls in the model window. Show tree is going to take in node index, selected index, and now it is also going to take in a reference to a pointer to node. So this will allow us to get both the index of the selected thing and the actual node itself. Index is necessary for ImGui stuffs, and the pointer is going to be necessary for graphics stuffs. And then we have a function here to set the applied transform. That'll just be able to set this matrix here. In mesh.cpp, we have a whole bunch of things. First of all, you'll notice we've added unordered map. And that is going to be used, let me see if I can find it here. Yeah, that's going to be used to map indices to structures of transform parameters. So now we can keep track individually of the transforms, the parameters for each of the nodes that we are applying transforms to. We keep track of the pointer to the currently selected node in addition to its index. And the way this works basically is, you know, if there is a currently selected node, then we're going to, you know, draw all these controls. Now the controls are going to be linked to a structure in our unordered map. We use the index operator here to access at that index. And if it doesn't exist, this will create a new one. So this will never fail to give us a structure to write into. It's either going to retrieve one that already exists in the container or create a new one. And then the transforms will be applied to that as we move the sliders around. Set applied transform is pretty much what you would expect here. And in ImGui is item clicked. Now we set the current node, and we also set the pointer to the selected node. This is kind of a weird one here, but I mean, the operation of showing the tree itself is a constant operation. It doesn't mutate anything. But what it does do is it changes an external pointer that will be used to mutate it in a future function call. So that's why we use the const cast here. Then in node, we have to initialize the applied transform initially to just identity matrix. And when we are drawing a node, we want to concatenate the base transform with the applied transform. with the accumulated transform that is passed in, and that will be the final transform for this node, and it is that final transform that is going to be passed in to the children. And that's how the transforms propagate and accumulate as we go down our tree of nodes. As usual, if I select the root, I'd be able to apply transform to the entire model. But if I select just the legs and rotate, you'll see I can just rotate the legs independent of the other nodes. And you'll notice, no matter which node I select, they're all rotating. Maybe that's not the right one. That's lights. There are no lights in this. They're not being rendered. Yeah, you'll see they all rotate basically around the same center point, which is located here between the feet. Because there is no hierarchy, you can't rotate the arms relative to the body, because that would require some kind of hierarchy in the model, which we don't have. And it's at this point that I decided, I'm going to need a better model now, a model with an actual hierarchy, so that I can test this functionality to make sure that the built-up transforms are working as I intended. The problem was that no matter what other format I tried to load, it would either it would fail to parse it with an error, or it would say that it parsed it correctly, but it would actually just take a big dump all over the data. Meshes would be missing, or the hierarchy would be gone, or something weird. Otherwise, it just didn't work. And I was actually ready to basically just throw in the towel and say that ASIMP is pretty much broken. So during my testing, obviously I realized that I'm going to need some way of, I'm going to actually have to check to see whether the model loaded correctly. So I've added an exception here to report errors on loading the model. And in mesh.cpp, let's see here, down here. I also added an extra post-processing step here to convert coordinates left-handed. But down here, when you call read file, if this pointer is null pointer, that means that there was an error, and you can get the reason by calling get error string on the importer. So I do that, throw a model exception, and I kept testing different formats. None of them worked. There's some other changes here in bindable. What did I change here? I removed this no except specifier on here. I guess it was causing me troubles, but otherwise nothing else. I just tried to load this model in GLTF format, GLTF 2.0. It's a very simple model with some hierarchy that I created in Blender. I believe it contains 3 boxes, but as you can see from looking at this bullshit here, and my windows are off the screen for reasons, there are no models. There's no meshes, and there's also no hierarchy. So it's broken. It is totally broken, and I was at my wit's end. I debugged it, couldn't see anything else. I talked to SlidyBat because he's had some experience with ASIMP even before me here, and he gave him the file, and he said he could load it fine. And after checking the versions of our libraries, found out that I have the same version as him, but mine is a much older revision. So the revision, or the version, that is on VC package isn't the most recent one, and it is highly broken. So I downloaded from GitHub. They have an installer on GitHub that you can download. I installed it, got the binaries and the include files from that. And that's in this commit here. You can see I've changed the library, added a bunch of header files here, and changed the DLL. Same version, but this one is the newest revision that they have on GitHub. And you'll see now, if we load it, we have boxes. There are actually 3 boxes, although you can probably only see 2 right now. Let's move the light out a little bit so we can get some more definition here. There you go. So you see we've got boxes. I can apply... No, there's a problem here. If I click this, you notice that it didn't select it right away. This one, you see, it doesn't select. You actually have to expand it before you can select. And we'll fix that later. But anyways, click on this, click on the root, and you'll see that I can rotate the entire scene. Look at that beautiful specular. But if I click on, for example, this cube child, I can move just this single child. Let's move it out a little bit. And then if I choose this one, the base, I can rotate this system. Well, it's not a rotation. I can rotate this system of 2 models, but this one stays put because this cube is completely separate. And then if you click the root, again, you can rotate all 3 of them together. So it is working as intended. Beautiful. Still got some issues, like not being able to select nodes if they're not expanded, but we verified that it works, and more importantly, we've actually got a version of the library now that isn't broken as hell. So that's what I call progress. So selecting non-expanded nodes, turns out it was a pretty simple fix. The problem is that we were only doing, and let me see if you can see it here. In the old code, we were only doing the selection processing if the node was expanded. So obviously, if it's not expanded, this code is never going to be reached, because this if statement is going to evaluate the false. It's not going to execute this code. So the way I assumed it worked was all the processing that would happen for this node would be inside of this expanded section here. But actually, isItemClicked works on the item that was added to the window last. So you don't have to put it inside of this if statement here. So what I did was I made it independent. I called treeNodeEx to generate that widget, and I store the return value in a variable here. Then I do the isItemClicked regardless of what this value is, and then I do the processing of the children based on that value. And that fixes that problem. The next problem is a little trickier, but basically, to make a long story short, what I've done here is before I was applying the base transform, so that is the transform of this node relative to its parent, and then I was applying the applied transform. But you actually want the applied transform to be in the node's own space. So you don't want to apply this transform after you've offset the node relative to its parent, because then any rotations you apply here are also going to rotate that offset. That's bad. You want to rotate the node around its own center in its own space, and then you want to offset it. So we had to change the order here. And I renamed base transform to just transform, because base makes it sound like it should be done first, when really it's the applied transform. It's just a little bit of renaming there. It doesn't matter. But that makes it so that our transforms will make more sense. Then I added the Hierarchical Nanosuit. So what I did was I took that object file and I imported that mother hecker into Blender. And then I took that, basically because the original one, the left and the right arms, they were just a single mesh. So I split the arms, I split the legs, and then I parented them all to body. So the arms and the legs are parented to body. The head, helmet is also parented to body. I parented the hands, the left and the right hands to the arms. I also had to split them. And I changed their center points. So for example, now this arm is going to pivot at the shoulder rather than pivoting around the middle of the feet. So I did all that stuff. I exported it to GLTF, and then I made this boy load nano.gltf instead of boxy.gltf. And there we had our beautiful hierarchical mesh, which I will show you in a second. But first, I made a change. Now that we've got all these windows on our screen, I'm running out of real estate. So I figured I want to make the window a little bigger. Instead of 800 by 600, at least, let's do 720p, because that's what my videos are at, right? So, make the adjustable window. We were doing a bunch of hard coding stuff. We were hard coding, well, the width and the height of the back buffer was being detected from the window itself. So that's okay, I guess. But here, for the depth stencil, we were hard coding as 800 and 600, and also for the viewport, which isn't good. So what I did was I made them all just be based on width and the height parameter that will be passed in to the graphics constructor. And this will also allow the width and the height of the back buffer to perhaps be specified independent of the actual window dimensions, which might be useful in some niche situations, but whatever. I make this all based on a single source of truth, which are these parameters that are passed in. And then in app.cpp, we pass those parameters in when we create the window. Beautiful. And the last commit here, I just remove a bunch of files that we're not using anymore. AsTest, cone, that sort of stuff. So, the moment you've all been maybe waiting for, let's actually take a look at the hierarchy and see what it looks like here. Now, this is weird. AsTest, app.cpp is trying to include something that doesn't exist anymore, which is weird because I'm pretty sure I tested and built that. I don't know why that even happened. But anyways, let's get rid of that. I'll just commit that at the very end. All right, here we go. lots of windows, but look, we have a lot more real estate now in which to put our windows. I'm going to get rid of the ImGUI demo window. Won't be needing that right now. We got our light here. We got our camera. We got our action. So first things first, let's get the body into a better position here. Yeah, it looks good. Let's bring our boy down. Let's bring the light a little bit closer to us. Yeah, that's looking good. Bring it off to the top layer. Ah, good. Beautiful. Okay. So we expand. Notice that now we can select nodes even if they aren't expanded, which is useful. Notice how our controls right away remember what value they had last. That's all due to our, unordered map system that we have. But anyways, we can rotate the arm relative to the body. It looks dumb, obviously, but you can see it works. And now we can rotate the hand relative to the arm, and that all rotates together as a unit here, and that all rotates together as a bigger unit here. That's the whole propagation of our transforms down the node hierarchy. We can do the splits. Look at this boy. He's so flexible. Lovely. He's loving it. Oh yeah. Oh yeah, boy. Oh yeah. So anyways, that's the dumb situation that we have here. But now you can actually get some hands-on first-hand experience looking at the actual node structure of our graph here, of our scene. Now, obviously, I mean, this isn't how 3D models of characters are actually animated in real life. I think you can probably guess that it's more complicated. They might have been done like this in like PlayStation 1 era, but now it's more complicated. You've got stuff called bones skinning, and for more advanced physics, you've got inverse kinematics. A little bit of a $10 word for you there. And we'll be looking at some of that stuff in the future. This sort of thing is more for, like, let's say you want to parent a weapon to a character. You would do that using a hierarchy of nodes. And even though real character animation is done using skeletal animation with bones, it's still a similar concept. The bones still have a hierarchy. So it's not like this stuff that I've taught you is a complete waste of time. It isn't. It's an important concept. Hopefully you guys will, have the foresight to be able to realize that. But there you go. Pretty cool stuff. I hope you will agree. And I mean, you could use it for something like, let's say you've got a tank. And so the tank has a tank body, and then it has a turret on the top that swivels. That would definitely be well suited to this kind of model system and model animation. Mechanical things in general, probably better for this, but things that are more squishy, you're gonna want bones, skins, that sort of thing. And we'll definitely be looking at, the animation of a rigged character in the future, but this is where we're gonna stop it for today. Now in the next video, the thing that's been annoying me for quite some time now is the positioning of the freaking camera is very annoying. It's annoying to have to position shit like this. So what we're gonna do is we are actually going to create a system where we can move through the world freely using the mouse. Much similar to the way you would move through the world in a first-person shooter. So obviously it's going to be useful to those of you who want to make games like first-person games, and it's just going to be, something that will make our life easier as we do more experiments. So yeah, we're going to do mouse look. We're also going to do hiding the cursor and some other Win32 API stuff like raw mouse messages instead of using the WM mouse messages. But until then, thanks for watching. Hope you enjoyed this video. If you did, please click the like button, helps a lot. And I will see you soon with some more Hardware 3D.